Okay, ladies and gentlemen, you are all welcome to my YouTube channel. Today we are going to look at how we calculate the average kinetic energy of a molecule. So generally we have two formulas that are used in calculating the average kinetic energy of a molecule. So we have a formula for calculating the average kinetic energy of an ideal gas for molecules, and the formula is E. The formula is E is equal to 3 all over 2 kBT. And the kB here stands for Boltzmann constant. This Boltzmann constant, and this Boltzmann constant has a constant value, and the constant value is 1.3. The constant value is 1.381 times 10 raised to the power of minus 23. So it has a constant value, and the constant value is 1.381 times 10 raised to the power of 23. While the T here stands for average temperature, and the temperature is usually measured in Kelvin. So if you have a temperature and the temperature is given in degrees centigrade, then you have to convert it to Kelvin. Like for example, in these questions, we can be asked to calculate the average kinetic energy of an ideal gas per molecule. So if you ask to calculate the average kinetic energy of an ideal gas per molecule, so this is the formula that you are going to use with. So now, for example, E, we can now say E is equal to 3 all over 2, and kB, of course, we said is constant. So that we have times 1.381 times 10 raised to the power of minus 23, and then times the temperature. So from the question here, it states that the temperature is a room temperature. So since the temperature is room temperature, so whenever we set room temperature, it means that the temperature is 25 degrees centigrade. So the temperature is 25 degrees centigrade. And of course, remember, if you want to convert the temperature into from degrees centigrade to Kelvin, we have to add the temperature in degrees centigrade, which is 273. So therefore, we have T is equal to 273 plus 25. Therefore, we have 298 Kelvin. So therefore, we are now going to see 3 over 2 times 1.381 times raised to the power of minus 23 times 298 in Kelvin. So after we have this, then we are now going to use our calculator. So after we freeze our calculator, we are going to have our final answer here to be, the final answer here is going to be 6.173 times 10 raised to the power of minus 21 joule. So this formula is actually used for calculating the average kinetic energy of an ideal gas per molecule. It's used to calculate the average kinetic energy of a gas per molecule. So, but of an ideal gas. So now in this case, that is not the case. In this case, we are actually going to calculate the average kinetic energy of 2 moles of oxygen gas at room temperature. So how are we going to calculate it? So we are going to use the second formula, not this one. This one is just to give you an idea on how to calculate the average kinetic energy of an ideal gas per molecule. So the second formula that we are going to use in calculating this is going to be the average kinetic energy, so the kinetic energy K is equal to 3 all over 2 N RT. N RT. And of course, the R is universal gas constant. The R is universal gas constant, which is always equals to 8.3145. But of course, it has a unit. And how are we going to get the unit? Remember, we have Phoebe is equal to nRT. So we can actually make the R subject of the formula. So here we have R N over T. Then here we have N over T. So this one will now cancel this. So of course, we have our pressure, which can be Newton per meter square. And of course, we have volume, which is of course meter cube. So it can be meter cube divided by mole per Kelvin. So therefore, at the end, the unit is going to be Newton meter per mole per Kelvin. So therefore, this one is going to be Newton per mole, Newton meter per mole per Kelvin. So we have this as a constant value. And of course, this is a temperature, and this one reflects the number of molecules. So therefore, how are we going to get this? So to get this is simple, since from the question, we have 3 all over 2, and then we have times the number of moles is 2. So we have 2 moles times the R is 8.3145, 8.3145, then times the temperature in Kelvin, which is actually the room temperature is 25. So we're now going to say 25 plus 273, which is equal to 298. So it's going to be 298 Kelvin. It's going to be 298 Kelvin. So here we are going to multiply it with 298. So after we phrase our calculator, we do all the calculations, then we are going to have the average kinetic energy of 2 moles of oxygen to be 7433 joule. Going to be 7433 joule, and this is going to be the answer. This is going to be the answer. So let's see another question. What is the average kinetic energy of 12 moles of chlorine gas heated to 50 degrees Celsius? So this one is simple. We are going to use the formula that we used previously, which says average kinetic energy is equal to, the average kinetic energy is equal to 3 all over 2 N RT. And of course, since the temperature here is 50, so we are now going to say 50. We are now going to say 50. Since we have 50 here, so we are now going to say 50 plus 273. So 50 plus 273 is going to be 323 Kelvin. It's going to be 23. It's going to be 32 Kelvin. It's 323 Kelvin. So 323 Kelvin is the temperature, and of course the R is constant. So it's now going to be 3 all over 2 times the N. Now I think Like, that is clear. I have to go back. Yeah, this is the question. So what I am seeing here is we are going to apply this formula K is equal to 3 all over 2 nRT. And the temperature given here is, of course, 50 degrees centigrade. So we have to convert it to Kelvin. So we are now going to say 50 plus the 273. So 50 plus 273, we are going to get 3, 2, 3, sorry, 3, 2. It's going to be 2, 3, 2, 3, 3, 2, 3 Kelvin. And of course, the R is constant and the number of molecules are 12. So we are going to have 3 all over 2 times the number of molecules. There are 12 molecules, and then times the R, which is 8.1, sorry, 8.3145, then times the temperature, which is 3, 2, 3. So after we calculate everything at the end, we are going to have 4, 8, 3, 4 joule. So this is the average kinetic energy of 12 moles of chlorine gas. So thank you, ladies and gentlemen. Thank you for listening. And if there is any, thank you for actually watching my videos. And if this is the first time you are coming to the channel, please subscribe.